So today I shall be discussing about implicit. In the last session we talked about mainly traits. Traits, I said that these are similar to interfaces. I mean, the logical meaning of traits is nothing but you want to add some new functionality to your application, you add it through traits. Now today we will be talking about the implicits here. So first we will be talking about implicit definition. Now, now, what do we mean by implicit definition, or why do we need implicit definition? The only idea of implicit definition is to add new functionality to your class. That's the and let's say you have class A which has method 1, two methods are defined, method 2. Now you want to add some more methods to this class. So usually what we do is, and we don't want to modify the same class, we say class B extends specific to some use case, we want to add some two more methods. So we usually what we do is we define one more class which extends A. Since it extends, it will inherit method 1 and method 2. Method 1 and method 2 are inherited. There will be nothing like this. It is inherited already. Or I will not, because we don't define anything inside the class B. It is automatically implicitly inherited. M1 and M2 are, I'll just write, inherited. Now, as I said, I want to add few more methods. I can define those methods here. Method 3 something and method 4. So we added few more functionality to our class. Some unique, some specific use case needed some two more functionalities or methods. We added this. So this is how we add new functionality to a class. We extend a class and add some methods which does that operations. Now sometimes what happens, they don't allow this class to be extended. Sometimes the source code is not available. Sometimes the source code of this is not available. This is part of a library. They give us the binary library. Binary library is given and we don't have the source code, and possibly it is defined as final. Now since source code is not available, you don't have the source code because it is provided by some third party to you. They did not give you the source code, they just gave the binary library. Since source code was not available, you cannot modify first of all the code because it's only the binary. Now since they have made it as final, so what does it mean is nobody can extend class A now. This you cannot do. You cannot do this. Now you are put into restriction. You cannot modify the code because it's a binary. You cannot extend the class because they had defined it as final. You will get a compilation error that you cannot extend. Now how do you add extra functionality? Extra methods. So this is where implicit definition comes into picture. This is where the implicit definition comes in. So implicit definition is nothing but is used to add new functionality to your class. That's the overall idea you need to keep in mind. Let's see how the example looks like. As usual, open the Scala examples that I had shown. Open the Scala examples. So in the Scala examples, you should see implicit examples. In that implicit, there is a implicit testing. Sorry, rational class, rational.scala. Inside that rational.scala, just open the testing rational. So to understand implicit definition, in fact, so we are trying to define a class to represent a rational number. Now, what is a rational number? A rational number is a number which has a numerator and a denominator. That's what we call as a rational number. Meaning 2 by 3 is a rational number, 1 by 6 is a rational number, 2 by 5 is a rational number, 7 by 6, 7 by 9 is a rational number. Anything. Half is a rational number. Anything that has a numerator and denominator is a rational number. You can also represent 2 as a rational number, because 2 could be written as 2 by 1. I mean, any natural number can be represented as a rational number, because you can always have a divide by 1 with this. So we'll define a class, we'll define a simple class called rational, which takes two members, numerator, which is an integer, val denominator, which is an integer. So we have certain method. This is only to represent a rational number. That's all. Now if I go and see here, I have a rational number which extends ordered of rational. We will see this later. This is not as of now required. Ordered is a trait actually. A inbuilt trait inside Scala math library. It is used for anything that is relational comparison. I mean, you want to do some comparison, greater than, equal to, lesser than, equal to, any kind of a comparison you want to do on your class, you can always extend the ordered here. It's a trait. It's a bit of a complex trait defined inside the Scala library. So we just forget about this. The GCD has been used here. I mean, this is no way related to implicit. The reason I'm just defining the GCD is sometimes you may have 2 by 4. You take just the GCD and it can be represented as half. That's the reason that GCD has come in. Not to worry about that. Sometimes after adding two rational numbers, you may get something as 3 by 6. You may get something as 6 by 9, something like this. So you just take the GCDs and you can make it as half, you can make it as 2 by 3 something. That's the reason we have defined that. We also are defining our own constructor which just takes a single integer. Now why do we need this? Because usually rational number should have a numerator and a denominator when we define a rational object. Here, as I said, natural numbers can also be represented because the denominator can always be 1. So we can create a rational number with just a single parameter. Not necessary both the time we have to give numerator and denominator, we are just giving the numerator. The toString method we are defining so that it displays the rational number in the form of uh, the way we have learned. Something on the numerator, something on the denominator. Now we have added a plus method. Now we have added a plus method so that two rational numbers can be defined, can be added. So this is the mathematical logic that we usually use to add two rational numbers. I mean, if I have something like 1 by 2 plus 1 by 4, obviously we will multiply the denominators 2 into 4. Then what we will do is we'll try to divide divide this value by 2, the first denominator. Whatever value we get 4, 4 will be multiplied by the numerator. Similarly, we divide again with this 4. 4, we divide this, we get 2, 2 will be multiplied by 1. So usually we do this, which is nothing but 4 plus 2, 6 by 8. 3 is a 2. Usually we do this kind of a multiplication. So that's what we have defined here also. Add two rational numbers. I want to add an integer also. Hence I am passing a rational number is being added to a integer. So we have defined which gives a new rational number after doing the addition. Similarly, we have defined our own minus method. As you can see here, we ourselves can use the symbols as methods. There is no restriction on that. Probably certain symbols may be restricted, but most of the symbols, arithmetic symbols, can be used as a method definitions. And Scala encourages to use that. This is a symbol. Subtracting a rational number. Multiplying a rational number. Multiplying an integer. Dividing a rational number. So certain methods are already defined in this rational number so that we can do some operations on the rational number. Now not just not to not to worry about these methods, but our main goal here is to understand implicit definition. So we have a rational number, so we can create a object in our rational number. I will say val rational1 r1 is equal to new, the way we create a rational number. I can say 1 comma 2. 1 is the numerator and 2 is the denominator. Internally it will be represented as, we are representing, let's assume it is r1 is equal to this. But internally is nothing but it is just an object. That object has 1 comma 2 values. This is our r1. N is equal to this, d is equal to this. We have val r2 is equal to new rational, I will say 1 by 1 comma 4, which we can say can be represented just a representation. Now we'll do val r3 is equal to r1 plus r2. We'll also do val r4 is equal to 1 plus r3. Now we'll do val r5 is equal to r4 plus 5. Now the question is, one of the expression is invalid expression. Now which expression is that? Out of these three, one expression is invalid. You will get a compilation error. Any guess on which will be giving a compilation error here? Which expression will be invalid? Right. This expression is invalid. This expression is invalid. Why this expression is invalid? Because you can see, what do I mean by r1 plus r2? We know that everything is an object. R1 is an object of rational. R2 is also an object of rational. So when I say a plus method, this plus method is nothing but the method that is defined in our class. This is that method. So meaning internally it will call which means on R1 object we are calling the plus method and passing R2 as an object. So we have defined a method already here. A plus method which takes another rational as an object. Here. So it works fine. We have already, this method is defined. If I say one more is R4 plus 5, the third one. R4 plus 5 means on R4 object we are calling plus method and we are passing 5 as the integer. Now if you see, that method is also defined. We have defined a plus method which takes an integer. That is also fine. It also works fine. Since that method is defined, so this works fine. Now our second expression, if you see, what does it mean? It means on integer object we are calling a plus method and we are passing R3 as the parameter. I mean, we are passing a rational number as a parameter. Obviously the plus integer does not have a method, a plus method which takes rational number as an object, because we just defined that class now. How can integer already include it? Integer only has plus method to take one more integer. Integer class has plus method to take one more double. It has a plus method to take one more string or something like. So the way the integer class is defined, some class int. So there is a plus method defined which takes an int. There is already a plus method defined which takes short, which takes long, which takes byte, which takes double, which takes float. So there are multiple plus methods defined which takes different parameter, which is already defined in the integer class. Integer class does not have a method, it does not have a plus method which takes rational number. It does not have. Then how can it add it? That's where the compilation error comes into picture. This is not defined in the integer class. So that's the reason this becomes a invalid expression. So I hope you got the idea of why this expression is invalid. I hope it was clear. And any questions on that?
Oh, yes, Pramod.
Yeah.
Can we write 1 colon plus R3, then it gets valid?
1
Colon plus R3.
colon plus R3. No, it doesn't. I mean, what was the, I mean, rationale behind asking this question? You had
No,
something in
actually,
mind?
yeah. I mean, you mentioned the way it validates when it is the plus, it validates on the left hand side, and colon validates on the right hand side, like that you mentioned. No, so that in that way, will this the compiler will start validating from the R3 plus, sorry, R3
Oh, no,
dot
no, no,
plus.
no, no,
Okay.
no, it doesn't. It doesn't. I mean, it's only you define which methods based on that. Not to get confused with the colon and plus here, but that was a, I mean, that was really good thinking. But what the way does it, we use a plus method. I mean, the way we define the method, only those methods can be used. Now when you say colon plus, this method should be defined in integer class. This is a method. I mean, integer class does not have this method. When I say colon, this is a method name. This is a method name. Just like plus is a method name. Just like plus is a method name, this is also method name. The only property of this method name is it is associated with the object on its right hand side. Just because it ends with colon. Now you have to define a such type of a method, but that is not recommended. That's not, I mean, relevant to this example here. I hope that was clear.
Yeah, thank you.
So what we were trying to say is this is our integer class. Since integer class does not have any kind of a method, you can write, since integer class has all these methods, we can say val x is equal to 10, val y is equal to 10. We can say val z is equal to x plus y. When we say this method is called. When I say this method is called. when I say uh, uh, a is equal to val a is equal to 100L. When I say this, a is a long. A is a long here. So if I say val m is equal to x plus a, in this case, this method will be called. So in this case, this method, because there is already a method defined which takes a long as a parameter, because this means on plus on integer x we are calling plus method a. Similarly, if we are adding a byte, this method will be called. If you are adding double, this method will. So that method should exist, only then you can do that operation. Since this method does not exist, since this method does not exist, you cannot, this operation you cannot do at all, because this 1 plus it actually means 1 plus this, and this method is not defined in integer. Now how can I solve this problem? How can I solve this problem? The one thing is, should we add this method in the integer class? Obviously it doesn't make sense to add this method in the integer class, because today we have defined rational, somebody else will define some other. There are millions of people, they will define their own class and methods, and if we keep on adding all those methods in the integer class, it becomes a very bulky. That's not a solution. You should not add this method inside the class to make it work. But how do we solve that? I mean to say, if you give this code, our rational code, if we give this code, if I give this code to some third party or some client, obviously the very first question they will ask is, if a rational number plus some numerical number works, why don't the numerical number and rational number work? If R1 plus 5 works, why doesn't 5 plus R1 work? That's the reasonable question they would be asking. For them, it doesn't matter how programmatically there are some loopholes, or how it is limited programmatically, but for them it has to work. For them, it's just an addition of one rational number and one integer, one numerical number. Whichever order they come, it should work. Now, how do we solve such problem? We should not give that excuses, right? It cannot be done. So this is where the implicit definition comes into picture, because it is not, first of all, it is not a good idea to modify the integer class. It is not a good idea to modify the integer class. It is also not a good idea to extend a integer class. It doesn't make sense, because rational number may not be a subclass of integer. Rational number is not a subclass of integer. I mean, logically it doesn't make sense. It is as good as saying extend. Uh, it is as good as saying. I mean, there is no. It is as good as saying class. We have animal, and I am saying class uh, BMW extends animal. Something like this. I just a vague example. I mean, there is no relationship between this. Why would we want a BMW to extending from an animal? So such kind of things you will get when we say like rational class extends from integer and all add all those methods. That doesn't make sense at all. Now the only way we can do is we add a implicit definition. So as I said, implicit definition is all about adding new functionality to your class. Now we want that new plus method which takes rational as a parameter. This we want to this method we want to this we want to add to integer class without modifying the integer class, because it's not a good idea to modify. So that's where implicit definition comes into picture. Let's see an example how we are doing. Or what we can do is, I'll show the example. So I'll first show the error here. As you can see, I have defined rational. I have defined rational 2. Everything works fine, because if you press the control button and if you hover on that plus, it will go and show where this plus method is defined. So as you can see, this is our plus method that we have defined in the rational class. Similarly, again, if I go and click on if I press the control button and hover on that, we will always see which is this minus method. Obviously, this minus method also we have defined in the class. If I see all the methods are defined. Star method is also defined. We have defined a division method also. Star method which takes an integer, plus method which takes an integer, minus method which takes an integer. Now you can see here it gives an error here. Cannot resolve reference plus with such signature. I mean, there is no such signature which takes a rational number. Or you click on the other error. So you can see here type mismatch, expected byte actual we are getting passing rational. Expected, you can pass byte, or you could have passed a character, you could have passed double, float, int, long, short, string. There are plus method defined for all these data types. There is nothing like a rational. Obviously it does not work. Now one solution is we can convert this to a rational number. We can convert this integer to a rational number. You just define a method. You just define a method, define convert to rational in any class, in one of the class, any class, or in an object. As I said, objects can be used as a utility methods. You can define, as I said, one more use case of object is some I will say helper. I will define an object. Inside this I will define a method called convert to rational, which takes a integer, because integer we want to transform as a rational. We define this, and this method will just create a new rational of that. I will just define a method which takes an integer and it returns an object of that method, rational object of that method. Now when I say this is our function, this is how I define this. Now when I say val r4 something 1 plus r3, so we know that 1 plus r3 does not work here because it will give a compilation error. Instead of this, the way we have to write now is helper method, or I will just say helper methods dot call this convert to rational, and pass 1. Now this function will return a rational object. On that we can say R. So wherever R5 I have something 5 plus R4 I want to make 5 plus R4. Again helper methods objects we have to call, convert to rational I will do, and I will have 1 R4. So this is one way of solving this problem. Every time you call this method, wherever you want to do this, every time we call this method, it returns a rational object. Now it is no more an integer. 1 is no more an integer here now. I mean, if I use this, if I write the in this way, if we try to solve, there are two problems with this. Not two problems, I will say two limitations to this. The first limitation is nothing but 1 is no more integer now. 1 is no more integer, it is a rational number. And also every time we have to call this method. Wherever you want to do some operations, you have to call this method. So that's a bit of a extra things we are in. Those are the two things, two limitations of defining such a method. So instead of this, what we do is we make this as implicit definition. When we say implicit, when we say implicit, we don't have to explicitly call this method. The compiler will implicitly call this method whenever it sees a integer. Whenever the compiler sees an integer, I mean whatever parameter we pass to this method, the compiler will implicitly call this. We don't have to do this. We don't have to explicitly call this. That one problem is solved. And the other problem was, I said that if I use this method explicitly, this will be now rational number, it will be no more an integer. But when we do an implicit definition, it is a rational number as well as a rational. Now 1 is, it becomes 1 plus R3. Now 1 is a rational number also, and now it is I mean 1 is integer also, as well as it is a rational number. So if you see, we have added some new functionality to the integer class without modifying the integer class. This plus method did not exist in the integer class. Now because of implicit definition, all the methods that are available in the rational are now available for an integer also. So it is just like saying in this fashion. So we have class int, we have this, which has plus method, which takes one more integer. We have plus method, which takes a long. We have plus method, which takes a double, and so on. Some methods are there. Now we have a rational class, or let's forget the rational class. We have some class ABC. We have some plus method defined with some object of type X or something. Type A. We don't know as of now. I'm just defining multiple methods here. There is a minus method. There is a integer method. There is a all these methods are also available here. Minus, star, division. All these methods are available here, but only for these types. Only for these types. It could be a double, or it could be a long, it could be integer, something like this. I have some other methods defined. I want to add all these functionality to integer class. We saw a certain problem with respect to rational. Let's say those methods are defined here, which will solve the problem. I want to add this extra functionality to this class, but there is no way that I could modify the integer class. I can modify this integer class. So this is where what you do is you define implicit def uh, some method name. Anything could be the method name. Let's say the method name is EFG. The method name does not matter at all. The method name does not matter at all. You just say, but the only thing that matters is what is the input parameter you are passing and what is the return thing. You will say new ABC of X. So when you define an implicit here, what this will do is it will it will enrich your integer to also behave like a ABC object. Now any integer will also behave like an ABC object, meaning integer it will have its all the methods. Along with that, it will also have all the methods of the ABC class. So that is done through the implicit definition. Not only you don't have to explicitly call that, the one more bigger advantage of using the implicit is all these functionalities are put in the integer class. Or we can say now integer object also behaves like a ABC object. All the methods of ABC object is available for integer. We don't convert it. Conversion means it will no longer be an integer. It is called enriching. You make the integer class a bit rich. It has now richer functionality because of this implicit definition. So I hope these things were the concept of implicit was clear. Now what we want to do is we want our integer to behave as a rational number also. So we just define an implicit which converts our integer to a rational number. So as you can see here, you just define an implicit. The name of the implicit method doesn't matter. Hence I am given, it could be anything. It could be anything because we don't call it. Internally the compiler calls. The only thing that matters is integer. The input parameter. Only thing that matters is input parameter. So whenever the compiler sees integer, whenever if you see now there is an error. Now there is an error. So we have to import this object. All the methods in this object we have to import. So to import all the methods, because this is not visible, this method is not visible to the compiler unless we import it. I'll just say import conversion object. From that, import everything. Underscore means just like using import all the classes in that object. So as you can see, we there is no more an error now. Earlier there was an error. Because of this, what happened? Now the compiler evaluated this expression. It came to know that plus integer does not have a plus method which takes a rational number. So it was about to give an error. Before it was about to give an error, it checked whether there is any implicit method defined in the scope. So obviously, since we have imported this method is available in the scope. So there was an implicit method which took integer as a input parameter and returned a rational number. As you can see, it returns a rational number. Now all the methods in the rational number is also available for the integer class. Now integer class can also access all the, now we have made the integer class bit rich. So as you can see here, this plus method is of the rational plus method. This is not the normal plus method. You can see an underline on that plus method. Underneath that you can see an underline. So that itself signifies that this plus method does not belong to the integer class. It was added to integer class through implicit definition. Now integer got a new functionality, hence this works fine. Hence this works fine. Now we did not convert an integer to rational. We enriched the rational here. What I'm trying to say here is, you can see here, this is what I wanted to say. When I say to integer addition, it still behaves like an integer only. A is acting as an integer also. A is acting as rational number also. So we have just enriched. So whenever you want to enrich a existing class where where you don't have the source code available, where you don't have the permission to extend that class, so in that case we can, and we still want to add some new functionality, this is the way we want to. This is the generic way I'm trying to say. You want to add all this functionality to your class. You want to add all this functionality to your class. You just define a implicit, pass that for which type you want to do it, and return the class of it. Here the only thing that matters is the input parameter and the return value. This doesn't matter at all. It could be anything. It could be anything. So if I say val m is equal to, so I want to add a long to a integer, to a rational number. Obviously this doesn't work because we have defined implicit only for integer here, int. So whenever the compiler sees an int, it will enrich it to a rational number. But whenever it sees a long, it will not enrich into a rational number. Hence we are getting the same error. So what we can do is, we can define one more implicit, define anything here, and say long, so we should be able to do it. So because we did not define a constructor which takes the int, we can define a constructor. I mean, in this we have not defined. That's the reason it is not working. We have not defined anything here, and not nothing is here. If I define something like this, I mean, we have to. This is not the correct way. This is not the correct way. should also define one more. Yeah, some lot of changes I have to make for this. For as of now, what I will do is I will just say to int. I just do this for let to for it to work. I will just do this. Now it has to work for you. So I hope the things why implicit definition is required is clear. You want to add new functionality where a lot of restriction is there not to modify the code. You define all those methods in some class and you define an implicit so that all the methods of that class can be included to some other class. I mean there is other way implicit. So usually you do instead of writing this, there is one more syntax implicit class uh, rational conversion. It states I think I don't remember the syntax, but it is something like this. Implicit class method definition. Let me check that syntax. Not to worry. And I don't remember that syntax. The thing is, you put multiple these things inside a class. That's all. Instead of defining implicit everywhere for different data types, you just define the implicit for a class and put all those methods inside that class. There is a slightly different syntax maybe. I don't remember it, but as of now we will keep it without the implicit. We don't use the, let's not use the implicit class, but it's almost similar. It's almost similar. So I hope the implicit definition was clear.
Uh, Pramod,
Yes, Kalan.
uh, in this example, so can we have two implicit definitions, which where both takes the integer as an input, but the new object that is created is one is on like new rational is there, and the other one will be new XYZ class.
No, it will put an ambiguity to the compiler to what it has to, uh, I mean, convert. You can
Okay, I
only
mean,
return a single object of some type. I mean, you can return us one type of object, not multiple types. So you are just saying you define one more class.
no. Within the same object conversion.
Right. I got it. I meant to say
Yeah,
I have a class ABC. You want this way, right?
yeah, ABC of X kind of thing.
So this works. I think I was wrong here.
So, I mean, since we are not defining anything here, we are just calling int only 1 plus R2 or 1 plus R3, and 1 being an int, and we are not telling that what is that method. I mean, we are defining the what is that implicit method for that one. So, uh, if we define in ABC, there is a plus method, in the rational there is a plus method which behaves differently.
Correct.
So, which will be taken by the compiler at that time?
Again, it is correct. The question is now what happens is now to the integer we have made it as a rational also. We have added all the functionalities of the ABC also.
Yeah,
Now ABC might have a different syntax of its plus method. Now rational has a different.
yeah,
It is just like adding few more plus methods. Uh, uh,
yeah.
so in that case, it always depends on the signature of the plus method. So I will just put something here. I have defined a class rational. I have defined a class rational, and I have method plus here, which takes one more rational number. Let's say I have this method. I have one more class ABC. I have defined a plus method, and I have a sorry, which takes a parameter of the type ABC. I have two classes. Now I have class integer which has multiple different methods here. So internally I'm using some object to define a implicit. One implicit, some name here, XYZ name, which takes a int and returns rational. One more implicit, EFG, which takes a int and return ABC. Now what, as I was said, I was wrong here. Now what it does is it adds all the functionality of rational and all the functionality of integer of ABC to this integer class. All this is added here. We are adding all the functionality. Obviously there won't come any ambiguity. Now whenever we call the plus method with rational object, this method will be called. Whenever we call the plus method with ABC, this method will be called. So I hope that was clear.
But nowhere it is. We are letting that interpret. I mean, the compiler know it is just an integer. That's all.
Right, right.
But
And I mean, what this does is, what this does is, it just adds these two methods here. Let's assume internally what it does. It defines plus method and rational is added. It defines plus method and adds ABC also. That's what this implicit definition do. Now as you can see that you can just imagine that you have a integer class with these two methods available. Now
okay,
on that integer you call r1, or on that integer you call just an object of abc.
okay,
So that's the use of this implicit. It adds these methods to your class which is of this type. So I hope, I mean, that was a good question actually. I never tried it in this fashion, but yes, you can add that gives us one more thing to think, that you can add as many functionality as you want. Today you added some functionality. Today you added these functionality to your integer class. Later down the line, you want some more functionality to be added, and it may not be related to rational number. The new functionality that you want to add down the line, it may not be related to a rational number. You define one more class and you also add an implicit for that class. So you can keep on adding new functionality using the implicit definitions as well. So I hope that was clear to everybody.
Thank you.
Okay, I removed the long run. So you can always see, sometimes you will in Spark also, you might have seen lot of implicit definitions, because underscore will be used there. Underscore will be, I mean, underline. Whenever you say an underline on a method, whenever you see an underline on a method, you can always say that it is not the method which is defined directly inside that class. It is imported through implicit. Somewhere else it is defined, and an implicit definition has been created to add those methods to the integer. You will see a lot of things in Spark as well. Now that is implicit definition. In a similar fashion, we have implicit value. Like we have implicit definition, in a similar fashion, we have implicit value. Slightly different concept than the implicit definition, but the technical things remains the same. What I mean by technical remains the same is, as you can see here the compiler implicitly called the convert to method. The compiler implicitly called these methods. We didn't have to explicitly call this method. Similarly, when I say implicit value, a value will be passed to a parameter implicitly by the compiler. We don't have to explicitly pass a value. So to understand that, so just I have, let's say I define a simple function. Simple function, a product which takes two integers and and gives the product of those two integers. And this is a traditional way of calling the function. This is traditional way of defining a function, and this is the traditional way of calling the function. So we have this. Now I don't want to, we are explicitly passing values for x and y. I'm passing 4 as the value for x, and I'm passing 5 as the value for y. We are explicitly passing that. Now I don't want to explicitly pass this. I want the compiler to pass the second parameter. Implicitly let it pass. I will only pass the first parameter. Obviously when I say in this fashion, it will give a error. Compilation error will be there. Now how do I make the compiler to implicitly pass the second parameter? This is where that currying syntax will be used. So we define the currying syntax and make the second parameter as implicit. The second parameter is made as implicit, and we define the function in this fashion. We know we are having here multiple parameter groups, that is we are having two parameter groups which we call it as currying. This is the use case of currying. I mean, as I said, there is no new concept behind currying. It's only the syntax that is used in different places. In implicit, and also you can use it in higher order function. Now let's pass only first parameter. Let's not pass the second parameter because we have defined it to be implicit. We are saying to the compiler now, with this syntax, we are actually saying to the compiler that you pass the value for the second parameter, that is y. I will not pass the value for the second parameter. Let's see whether it works or not. So as we can see here, again we are getting the error. Could not find implicit value for parameter y. So what does it mean is, with this syntax, we set to the compiler that you pass a value for the second parameter, but the compiler doesn't know what value it has to pass. It doesn't know at all what value it has to pass here. So we have to define some implicit value here. Implicit just is z is equal to 10 something. Implicit val z is equal to 10 something. Now when I call this method, with only the first parameter, and when we are saying to the compiler that you pass the value for the second parameter. Now the compiler will check whether there is any value in this scope. Obviously, there is z defined as implicit, which is in the scope, and its type is integer, hence z will be passed as a value here. Hence z will be passed as a value, hence we get a positive. 4 and 10 is passed as a parameter. 4 into 10 is made. That's how the implicit value works. But if I have multiple such value, this it will not work. So now the compiler gets an ambiguity whether it has to pass this or whether it has to pass this. It cannot pass both. It has to pass one of them. So obviously it gets a thing here, ambiguous implicit values. So you have to define only one value here. Now what is the use case of implicit value? We saw the use case of implicit definition. You want to add some extra functions to your class by not modifying that class, defining it somewhere else, so we can do that. So what is the use case of implicit value here? Just to understand we just saw the implicit syntax here, implicit value syntax. Let's see the use case of implicit value. To check the use case of implicit value, let's go to the code once again. We saw implicit here. We have implicit parameter. So this is our implicit parameter. To understand implicit parameter, I am making use of the merge sort example to give a use case of implicit parameter. So just to give a refresh, what is merge sort? So what is merge sort? Merge sort is nothing but you have two collections. You have two collections, like we can have 9, 2, -1, 5, 6. something. Here we have 4, 4, 3, minus 2 and 7 something. Oh, sorry. It will not be in this fashion. I have minus 2, or just write simple things. I have uh, 4, I have 8, I have 10, I have 13 something. Here what I have is, I have minus 2, I have 0, I have 1, I have 5. So the way merge sort works is, the very first requirement for the merge sort work is, there has to be two collections, because we have to merge those two collections, and both the collection has to be sorted. These are the two conditions for the merge sort to work. Two collections, both should be sorted. Only then merge sort works. We know that 4, 8, 10, 13 are in sorted. Minus 2, 0, 1, 2, 5, 1 and 5 is sorted. Only then merge sort works. The way the merge sort works is, it will compare the first element. Whichever is smaller, it will put it here first. Again, it will compare this second element with the first element here, because this is not been put. Obviously, 0 will be put here. 1 will be again compared with 4. Obviously, 1 will put here. 5 is again compared with 4. Now 4 will be put here. Now 8 is 5 is again, or 8 is compared with 5. Obviously 5 is put here. And the rest we are only left with the other things. And so obviously this is how the merge sort works. We we should have two collections, both should be sorted. That's the idea of merge sort. Now how do I use a merge sort on a single collection? Now I say I have a collection as minus 9. Sorry. I have a collection as 9, minus 1. I will have 2. I will have 7, 0, 3, something like this. I have a collection like this. I want to apply merge sort on this. How do I apply? I want to apply merge sort on this. How can I apply the merge sort? Any guess on how can we apply the merge sort? No, there is no. I mean, we have to arrive at that. We have to define our own method which does a merge sort. But how do I do that? Because the merge sort requires two collection, right? So as said, Mohan said, we have to divide this collection, split this collection. Let's say we divide it as, we divide it into two collections. So this condition is satisfied. But are those both sorted? Are those both sorted? Obviously, they are not sorted. So that also condition has to be done. So how that condition is met? So what we do is, we keep on dividing it. Probably minus 2 may come here, and sorry, minus 2 may come here. 7 comma 0 may come into 1, 3 may come. Again we keep on dividing it. Keep on till what you will keep on dividing. I mean, we divided this again. We divided this again. We divided this again. We divided this again. Hence we got. So we keep on dividing until we get a empty collection or a single element collection. Obviously, we know that this collection is sorted because it has only one element. Even if we get an empty collection, that element is sorted. So we have now two collections. These two collections. These two collections are sorted collections because they have only one element. Hence, when we merge these two, we'll say -1, -1. 2 will be kept as it is. Here we are merging 0, 7. We'll merge these two. And while merging, now we have to merge these two. Obviously, -1, 2, 9 will be 0. Then we will have 3 and we'll have 7. So we now have the sorted function. Now we'll have -1, 2, -1, 0, 2, 3, 7, and so we know that this is how the merge sort is applied on a single collection. Divide it till what you divide, till what point you keep on dividing your collection. You keep on dividing your collection until you get a single element collection, or sometimes you may also get a empty collection. So both single element collection and empty collections are sorted collections, because empty collection is a sorted. If you have only one element, that is also a sorted. So then you keep on merging these empty collections and the sorted collection. So we will be applying the same logic. Programmatically, we'll see the same logic in Scala, but not to worry about the logic here, because our main understanding, because we are just trying to understand how the implicit parameter works. Implicit parameter works. So I have defined a method called merge. We have defined an object. I have just given a version 2 because we have different versions to understand how to arrive at implicit parameters. So I'm defining a merge sort which takes a collection of integer, and all the logic is written here to merge, to merge, sort, and merge. So what the logic you can see here, we are passing a collection length we are taking, and we are dividing it by 2. We are dividing it by 2 and we are putting a condition here. If when we divide the length by 2, if we get 0, we have to return that collection. And what does that condition mean? This condition checks whether collection is single element or empty collection. We can verify that. We can just verify that. So if you see here, there are how many elements? 1, 2, 3, 4, 5, 6 elements. So when I say 6 by 2, length by 2, we get 3. So when we say length by 2, we get 3 here. Now after that, let's say we divided. Now we have only 3 elements. When I say 3 by 2, how much I will get? 1. Let's say again we kept on dividing. So let's say I got 2 elements. 2 by 2, how much I will get? 1. Again we divided. We have only one element. 1 divided by 2, what is the value? 0. So what it means is, if we get 0, stop dividing there. Stop dividing there. Because we have to stop somewhere the dividing, splitting of your collection. So we have to have some condition. So if we get 0, it means that it is either a single element collection or a empty collection. Empty collection means there will be no elements, divided by 2 is also 0. So that's what it means. This is where you stop. Just return the values now. Stop dividing and return whatever we are having. And that's what condition we have. If it is not 0, then keep on dividing. Keep on dividing. I mean, we are using a definition inside a definition, a method inside a method, a definition inside a method. So let's see how it works. This function will actually do the merge, but before doing the merge, we have to split. Length by 2 will give you 3. Split at the third index. Split it. So we got first half and the second half. Now pass that first half and the second half to merge. We want to merge the first half and second half, but before merging, again split it. Again split the first half. Again we call recursively this merge software, which will again check whether it is divisible by 2. I mean, whether it is 0 or not, and again it will keep on splitting. It will keep on splitting the until it sees a 0. Once it sees a 0, it will return that. It will return that collection. I means the merge will get that collection as the input parameter. From here we'll be returning. From here also we'll be returning. Now we get those single element collection, or it one of them may be empty collection. Now the merge method will be called. Now the merge takes two collections. It could be an empty collection or a single element collection. We are doing a match expression here. We have already learned what is a match expression. We are passing those two collection as a tuple. This is the first half collection. This is the second half, which one of them could be an empty or it could be a single element. Now here, from here, the merge method is being called. From here, split method was being called. Split, split, split. And from here we are calling the merge. Let's say, not here, uh, from here. But from here the merge will be started, which will merge the two elements. We are passing those first half. We are passing, this is the first half, this is the second half, and we are checking through the pattern matching whether if the second half is empty, just return the first half. If the first half is empty, just return the second half. That's how we are doing just the merge. Now what does this mean? What does this mean? Okay, I think we have only seen what is the colon method is. We have already seen what is a colon method is, but we did not see with the pattern matching. We just saw colon in this fashion, right, which adds an element to the head of the collection. If I say val nums is equal to list of something like this, we know that list class has a method colon colon. So if you want to call it, we will associate with the object on its right hand side. I will say val nums2 is equal to, I will say 10 colon colon nums. So we have already seen this. We have already seen this. It means on nums method, on num's object, colon colon method will be called and 10 will be passed as a parameter. But this functionality says that you are adding an element to the head of the collection. That's the only functionality it tries to say. When we use it in this fashion, we are just trying to say is colon colon method is trying to add a element to the head of the collection. Now what does it mean? The meaning of colon colon method changes when we use it in a match expression. When we use it in a match expression. When we use it in this match expression, what it defines here is it checks whether the collection has at least one element. It checks whether the collection has at least one element. So what I'm trying to say here is, I think I did not showcase the example. So I have something like this. I think I did not show this. So as you can see here, or we can also define val nums is equal to a list of, instead of saying list of, I can just say 4 colon colon 5 colon colon 6 colon colon 7 colon colon and empty. I can also create a collection in this fashion. How does this work? We know that we have an empty collection. On this we'll call the colon colon method, to which 7 will be passed as a parameter, hence it will add an element to that collection. So we'll get a 7 added to this collection. Now we have a collection with one element. Now we have a collection with one element. Now 6 will be added to this, hence 6 will become the head of the collection. Now we have a collection with two elements, to which 5 will be added to the head of the collection using the colon colon method. Now we have a collection with three elements. Now on that we are again calling colon colon method, and we are adding 4, which adds an element to the head of the collection, hence we get the 4 collection. So obviously the last, if you see, you need to have an empty collection. You need to have an empty collection at the last, because if I don't put an empty collection, it will try to call colon colon method on integer class, but integer does not have a colon colon method at all. There is no member called colon colon method. So you can see here, there is not a member of integer. So you need to have a empty collection. Or I can say val nums1 is equal to 8 colon colon. You are adding one more element. You are adding one more. So what I'm trying to say here is, the last one should be an empty collection or a existing collection. Whenever we use a colon colon method, the last should be a collection. Either that collection could be an empty collection or a existing collection. Just keeping that in mind. So when we use it in pattern matching, when we use this in pattern matching, what we will get. When we use this in pattern matching, so we know that this can be mapped to an empty collection, or this could be a an exist or some collection with some elements. If you map it to an empty collection, there are only three elements in this collection because it will be empty. Now, if it is not an empty collection, obviously there will be some elements in that collection. There will be some elements. So so there will be more than three elements in the collection. So what I'm trying to say here is this case defines this case defines that I will be true only if at least three elements are there. It will match only at least three elements you are passing as a collection. That's what it says. So obviously if you see we are passing a collection with three elements, this pattern will match. Because it says I will match only if there are at least three elements. After that, what it will do is R will be binded to X, character R, character G will be binded to Y, character B will be binded to Z, and we know that we have an empty collection also because you can imagine it in this fashion. List of RGB can be imagined as RGB, something like this, and at the end we have we can imagine R. So uh, this is how a collection is created. Whenever I say RGB, we have R, we have G and B, and then we have a empty connection. So I can map it in this fashion. R will be binded to first element, G will be binded to Y, character B will be binded to Z, and we know that internally there will be an empty collection. Empty collection will be binded to X. So just intuitively think that, don't not to go more in depth of this. This will try to say that I will match an expression only if there is at least three element collection. So in which case it is matching. So if I say the same thing, instead of this I will have P comma Q. The same thing I will pass return access. I will return access if nothing else matches. If nothing else, in the default case, I will just return empty collection. Now, what does this say? Again, everything remains the same. I will match an expression only if it is a at least three element collection. Now, R will be binded to this. G character will be binded to Y. Character B will be binded to Z. And rest is taken as an existing collection, and PQ as a collection will be binded to X. Since we are returning X's, X's should be a collection with P and Q. So we can see that X's is a collection with P and Q. Just imagine in this fashion. First character binds to first this, second character binds to second, third character binds to this, rest of the elements, instead of characters, rest of the elements gets binded to the last value binding, last identifier, and it can be represented as a collection. Now only thing we have to remember this is what it says. It says that I will match at least three elements. So I mean to say, if I say something like this, if I pass two element collection, now it this says this I will match at least three elements. Obviously there are no, I don't have a collection with three elements. I have only two elements. Obviously this will not match. So hence it will go to the default case and it will return empty collection. So we can see that it is returning the empty collection. Now if I redefine mine, instead of saying this, I will say I have only x and y. Now this means that I will match at least two elements. If I receive a collection with at least two elements, I will match it. So obviously in this case the first will match because we have two elements. We have two elements. This case will match. R R character will be binded to x. G character will be binded to y. X's will be empty. So in both the cases we get the same thing. Let's say that instead of x's I will return x. So just to clarify that it is not going to the default case. It's not going to the default case. As you can see, we are returning r. X, because we are returning x is binded to. So just keep that in mind. Whenever we use in this fashion, it means we are trying to say at least here. So when I if I come back to my Scala example, so what we are trying to say here is this expression contains at least one element. I mean the collection that we are passing, it has at least one element. The second half also has at least one element. First half also has at least one element. So we just extract the first element. That's the use case of using the match expression. Check and extract. Check and extract. We checked whether it has at least one element. Then we are comparing the first element of the first collection with the element first element of the second collection. And we know that this means whenever it's not used in the pattern matching, it means we are adding an element to the head of the collection. If x is lesser, add x to the head of the collection. If y is smaller or lesser, y is smaller or lesser, add y to the head of the collection. That's what the logic says, right? Now if in this case, if -1 is smaller, add that to the head of the collection. Again the same things happen. That's how we are doing the merge. Not to worry about the logic. The every logic works fine here. The logic works fine here, but it has a limitation. What is the limitation here? What could be the limitation here? This method has a limitation. The sorting works fine, but still it has a limitation. Just keep in mind that I think we have learned a lot of things here, but our main goal is to go towards understanding implicit parameter. Understanding implicit parameter. The problem here is it can only sort integer collection. Yeah, ascending order, descending order, we can do that. We can do that. You slightly make changes. We can do such things. But the main thing is I mean, that is also a problem, but that will not help us in understanding implicit parameter. The main problem what I'm talking here is it can only sort integer collection. I want to sort a double, or I want to sort a string. I want to sort some user defined collection. I want to sort a user defined collection of users, collection of employees. I want to sort those things. Obviously, this function will not work. Right. To access to do such a things, we have to define the type parameters. Now we have to define the type parameters. We already know what is type parameters. We have already seen the type parameters. So we have my second version, second version of our merge sort. In the second version, we are saying let it be a collection of some type. Now it has become generic. It is not just restricted to integer. You can pass any collection here. But the problem arises, we can no more use this less than method because it may work on integer. It may work on integer, but on other objects, how it will work? Less than object may not be less than method may not be defined. If we usually use in strings, we usually use compare to method. On integers we usually use less than method, val x is equal to 10, val y is equal to 20. We usually say x less than y. This could be used because less than method is defined on a integer. Sometimes, let's say, usually on string, if I say val s2 is equal to 10, we say whether s dot compare to method is there, and we pass. So we use this. If you want to compare or compare two elements, two strings, there is a method called compare to. If you want to compare two integers, we use this. If you want to compare two doubles, we use this. To compare two doubles, we use this, or compare two integers, we use this. But to compare two strings, we use this. Now we cannot define a function like this. Now we cannot define a function like this for our next version here. So if it is an integer, we have to pass less than method. If it is a string, we have to pass compare to method. Compare to method. So dynamically we have to choose which method we have to pass to do the comparison. So that's the reason we define one more parameter group in which we pass a function as a parameter. This is also one of the use case of the higher order function. Now our merge sort version 2, version 3 is a higher order function which takes a function as a parameter. So if it is integer, we pass less than method, and if it is a string, we pass compare to method as a parameter. And this less than method will be called. Less than method will be called instead of instead of instead of this we are using. So if you see our method definition, or the way we are calling it is in this fashion. So merge sort version 3 we are calling, and we are passing the collection as the first parameter group. Second parameter group we are passing this method. We are passing this function. If it is an integer, we are defining one more collection of words, which is a collection of string. We can pass the collection of string. Now we have to pass compare to method here. Here we pass less than method. Here we pass compare to method. Now again, it does not look so elegant. It does not look so good to write such kind of a function. We want to have it as simple as possible. The sorting function should be as simple as possible. So for that reason, we are defining one more version of merge sort. Fourth version of merge sort. So in the fourth version of merge sort, first parameter remains as it is. We are passing a collection of some type. We have changed the second parameter group. Earlier the second parameter group was we were passing a function. Now what we are doing, we are passing a object of ordering. Ordering, as I said earlier, is a complex trait defined inside the Scala library, which helps in any kind of comparison. It helps in any kind of comparison. It has already defined all the comparisons there. It has already has less than method, compare to method, equal to method, greater than method, less than equal to method, greater than equal to method. All the methods are already defined in this class, in this trait. We can directly use that. We can directly use that. As you can see here, in this case now, order dot less than, because this less than method is already defined in this order object, ordering object. So instead of we ourselves defining everything, we can use the ordering object, and it will automatically call, this will automatically call, if it is an integer it will call less than method, if it is a string it will call compare to method. It will do that automatically. We don't have to worry all those things. We have to just pass, ordering of integer or order of string. So if you see, my next version, is nothing but we just pass, because we are passing a integer collection, we just say ordering of int. We are passing a words collection, we are just saying ordering of string. So based on this, it will try to call compare to method. Based on this, it will try to call the less than method. Now again, it does not look so elegant. Again, it does not look so elegant here. We want it as simple as possible. What we make it here is, we make this parameter as implicit parameter. So that's our last version of how to simplify our merge sort. So as you can see, our last parameter, the order parameter is being made as a implicit, means the compiler will pass this parameter, the value for this parameter. The compiler will pass the value for parameter. We just have to pass the connection. So as we can see here, I just have to pass the collection. I have to just pass the collection. The compiler will take care of passing the second element of the collection, which is our ordered collection. So we got very simplified API. Instead of writing in all this fashion, we got a very simplified sorting function. That's the use of the implicit parameters. You take care of all the complexity, hide all the complexity in some function, expose a simple API to the users or the developers. Make it more generic. Such kind of a stuff we want to achieve, we use the implicit parameter. Just hide some of the complexities so that it becomes users to use in a much elegant fashion. So that's the use of the implicit parameters. I hope the implicit parameters was clear. Now the compiler will pass the ordering object automatically. We don't have to specify that explicitly. It will see that we are passing a collection of integer. It will pass ordering of integer. If we see we are passing a collection of string, it will pass ordering of string object implicitly. We don't have to. So I hope that was clear here. So there already exists a, if I have val colors is equal to a list of blue, yellow, red, uh, green. So if we see this collection, I want to sort it by the length of the collection. I want to sort it by the length of the collections. How do I sort it? I mean, if I sort it by the length of the collection, red has length 3, hence red will come first. Blue has the length 4, blue will come second. Green has the length 3, 5, it will come third element. Last element will be 11. So we already have a method called on collection. We already have a sort by. We already have a sort by. Again, sort by is a higher order function as well as a implicit parameter function. We'll see the implicit later. First we'll see the higher order function. It is a higher order function which takes a function, and whatever that function that we pass as a parameter, whatever it returns, based on that the sorting will happen. It takes a function, and whatever this function returns, based on that the sorting will happen. Since I want to sort it by the length of each element, I can define a function that returns a length. Let's say I define get size, which takes a string, and let's say a star. I return the size of that string. So if I say get size, if I say Scala here, it will return 5. It will return because the size of the string is 5. Now, as I said, on colors there is a sort by method. Which takes a function, and based on the return value of the function, the sorting will happen. Now, if I pass this function, it returns the size. Hence, based on the size, the sorting will happen. So that's our sort by function. If I pass this get size method, it's a higher order function. As I said, this function will be called for every element. For every element, it will get the size. Finally, the sorting will happen on the. So we know that as we can see here, we got red first, blue, green, and yellow. Now, how does the sorting work? So if you see the definition of this sort by, if you just press the tab once again, you'll get the definition of sort by. As you can see here, the first parameter group is a higher order function which takes a function. This is nothing but it is taking a parameter which defines a function. So we are passing a function. Get size will be f. If you see, the second parameter group is nothing but our ordering. This is where the implicit is being defined. So the second parameter group is implicitly passed by the compiler. And what type of ordering it will pass? It will pass the ordering of B. Now what is B here? B is the return type from our function. In this case, our function returns integer, hence ordering of integer is passed, hence the size will be compared. If you want to return something else, based on that, if you want to compare with something else, based on that, ordering of that will be passed. So let's say I want to compare with the I want to compare with the second character. I want to sort it by the second character. Obviously, E will come first. E, there are two E's, red or yellow will come first. Then uh, blue will come third because second character. Green will come last because R is last. So we want to sort it by the second character. So I can define a function get char to get the second character. It takes a string, it takes a string and it just returns the second character. So as you can see, if I call this get character on hello, if I call it on hello, so you can see it returns the second character. So if I pass this function to the sort by, it will sort by the second character because I always said that it whatever the function returns, based on that the sorting will happen. So when I say colors dot sort by, and if I say get character is passed as a function, so we can see that yellow or red will come first, then blue, then. Now how it is working, because it returns a character and implicitly an ordering of character will be passed as a second value for the parameter. So using that, it will start. Now I hope the implicit parameter was clear. I hope the implicit parameter was clear, and also we discussed the sort by method here. So any questions on implicit definitions and implicit parameter? So if there are no questions, we will wind up the session here, and we will continue tomorrow. From tomorrow we'll start with the Spark. So that ends the Scala here. Tomorrow we'll start with Spark. Thanks everybody, and let's start tomorrow with the Spark.
Thanks, Pramod.
Thank you everybody. Have a good night and have a nice day.
Thanks, Pramod.
Thank you.